All right, so like I said, this class could be 5 minutes, it could be 5 days, however long you guys want it to be. You guys want me to move on from a slide, just say orange, apple, tangerine, whatever you want. Just shout out some kind of code word. But what we're going to be going over today is the evolution of Scout Sniper reticles. I'm Sergeant Cockrell. I'll be giving this class. Just let me know, like I said, how long you guys want it to go. What we're going to be going over is the evolution of reticles and technology that the Scout Sniper scopes used over time from like the Vietnam War up until what we have today. Scout Sniper features, or scope features. What is a mill? Like I said, what we'll go into over that is going to be later on in the slides, and I'll cover it more then. The Tremor 3 reticle, which is what we use now today, it's the most advanced, probably the most advanced reticle that we use right now, or what we have. Capabilities of the Tremor 3 reticle and everything you can do with it. What is a dope? We'll go over how to get your dope and all that stuff, wind calls, everything. And then range estimates using the Tremor 3 reticle and what we used to use before we had the Tremor 3 reticle. All right, so the first thing, what we had all the way from the very first scope up until probably what you shot when you were a kid, when you went out with your dad or grandpa, whatever, hunting, was just this regular crosshair reticle. And how do you figure out how high to hold and wind and all that? You just use Kentucky windage, which is, you know, aim an inch or a foot over that deer's back, shoot, and you're just swagging it. There's no scientific guess to it. So what we came up with after that is the mill dot reticle. So like I said, I'll go over what a mill is later, but this actually gives you, with these dots all the way up, so we'll have 0, obviously the center, 1 mil, 2 mil, 3 mil, 4 mil, 5 mil. After that 5 mil mark, you can't really go up or down anymore, or side to side, so you have to adjust for that. But when I go over the mils, you guys will kind of understand what this means, and it gives you an exact point of reference to aim on a target. I'm going to go over what parallax adjustment is real quick, just because I know a lot of people, they'll buy a scope out in town, like when they're not in the Marine Corps, civilians, everybody will buy a scope. And how many of you guys have scopes or shoot outside of the Marine Corps? Anybody here? Just one guy? Okay, so if you do ever find anybody that has one, or you're shopping for a scope or anything like that in the future, you're going to find one of these knobs. That's a parallax adjustment knob on the left-hand side of the scope. And what that does is it will take your reticle and line it up on the target. So exact definition for parallax is the apparent movement of the reticle across the target when the position of the head is slightly moved. So when you're sitting behind a reticle like this, it depends on where you have your cheek at. Wherever your cheek weld is, you'll be sitting behind your gun, and if you move your head at all and that crosshair is lined up on a target, that crosshair will actually move across the target. So when the position of the head is slightly moved, that reticle is moving across the target. So when you're adjusting your parallax, you'll see these have a number from like 0 to 100 to 500 to infinity, or something along those lines. It's pretty much your yards or meters. It's just a reference. To get it exact, there's a lot more that goes into it. You can set the gun down on its tripod and put your head behind the scope and move it. If you got that set for 500 and your target's at 500 yards or 500 meters or whatever, you can move your head back and forth, and if that reticle moves across the target at all, just move it left or right or front and back, whatever you decide it is, and keep on moving your head across that target and that reticle, and when it stops moving, that's when you got it set just right. So what I used to do is I just used to put a piece of tape around this and not even look at those numbers, because they're usually off anyways. Like sometimes it might be a 200 on this for a 500 yard target. So I used to put a piece of tape on there and just adjust it to my eye, to the scope, to the target and then write on there, like, this is what 500 yards is, or this is what 200, whatever. But this is something that a lot of people don't understand. They'll get it and they'll be like, yeah, that target's like 200 yards away, I'll just put this thing at 200 and I'm good. But like 95% of the time it's probably not, because everybody's eye is different and it's going to be different. Just like if you pick up somebody's gun that's zeroed and you shoot it, it's probably not going to be zeroed to you. So it's the same concept. And if you have a different cheek load on your gun every single time, say I have it here, I lift my head up and then I have it over here, that reticle is going to move across the target and you're going to be completely, your shots are going to be all over the place. So that's the main feature of this thing. It just moves that target or that reticle to the target. So basically, I mean, say you have a target right here at 500 yards and I'm sitting back here. If you have that reticle set at 300, it's going to be right here. So when I'm looking at this, I move my head and now the reticle is lined up all the way over here instead of the target that's over here. So when you're moving that parallax knob, you're taking that reticle and you're moving it to the target. So now when it's set at 500, you're back here and you're moving your head and that reticle doesn't move at all. It's stuck on the target, right? So does everybody understand that? That's exactly what you're doing. You're just moving that reticle in and out. So what is a mil? A mil is basically just a measure of degrees or just a measurement. Just like a compass has 360 degrees. Also, in the metric system, there are 60 radians and 6,283 milliradians in a circle. So what a mil is a mil radian. So when I'm talking about mils later on, and you're actually looking at the mil dots and the lines in the scope and on the reticle and everything, all that is just a measurement. You don't really need to know exactly what that measurement is. Just know that I'm talking about a scientific measurement, and it's going to give you a scientific spot of where to aim and how to adjust your scope and everything like that. Just like MOA. Do you guys know what MOA is?
Meaning of angle.
Yeah, so it's how you adjust your scope. Even RCOs, red dots, everything. Just adjusting it.
Have you guys done land nav and use mills at all? To understand? So
Yeah.
it's like to put it into like 360 to 6,283 is a pretty large change. I'm pretty sure it's like 17.7 mils per degree.
Yeah, it's something like
Yeah.
that. 17 point something.
Yeah, there's 17.7 or 17.6, but it's just a more accurate measurement of angle.
For the previous slide, is it the same thing if you use your rear for a rear sight post when you like change the diameter of the?
No, on the rear sight, all you're doing is, you're talking about on the iron sights.
Yeah.
No, so all that is just, instead of having my point right here on the tip of the gun, you know, the first iron sight, and having a huge circle where you can't really guess exactly where the center of that's at, you're just closing it up to get a better reference. So if this is here and you have this big circle, you might be over here a little bit and not even know it, but when you close that circle up, then you can get a more exact.
Okay.
So it's kind of the same idea, you're just making it a more exact sight alignment, I guess.
Because what parallax technically pushes the reticle deeper inside the optic, right? So
Yeah.
kind of how it's like you're just pushing it closer to the target. So if you're looking through a toilet paper and you have like a pin in the middle versus a pin on the end, it's going to do the same thing as kind of what he was explaining.
It's like taking this and if you're, that guy has got some offset shoulders. But if you're looking at this reticle right here and you move your head over here, it's actually lined up right here. And now next time I have my shoulder cheek over here, it's over here. So if you're moving that parallax, you're moving it like this. So the farther away from that target that parallax is, if that target's at 500 yards and I've got this set for 100 right here, you've got a huge adjustment for parallax right here, or movement of that reticle. if you put it right here at 500 yards like it's supposed to, I could sit all the way over here on the reticle, and reticle's still on the target. That's all it's doing. So a lot of people will try to shoot and they'll try to get a really tight group on a target, but they won't have their parallax set. So the bigger off, or the more off that parallax is, the bigger of a group you're gonna have. It could be all over that target, or you might not even hit the target. But if that parallax is set perfect, then you're gonna be able to hold a tighter group, or have a tighter group. Well, get on that. And this, like I said, it's just a measurement. I'm not going to go into it too much because it's a whole other beast, and we'll be here for like 2 days trying to explain it. This is kind of a chart with a reference. So 1 mil at 100 yards is 3.6 inches. And so on all the way down to 1,000 yards. So with that mil, a mil is a mil is a mil. It's a mil no matter what. So if I'm looking at this and I set this thing to 1 mil over here, if you look, I'm not moving this, I'm only moving it down there. So just like if I'm moving the reticle over here for wind adjustment, or up here for wind or elevation adjustment. So if I'm moving this, it might only be 3.6 inches here at 100 yards, but down there at 1,000 yards, it's 36 inches. So that's what a mil is. It's going to change with the angle and the distance. So what we use today, the most advanced reticle that we have is the Trimmer 3 reticle. You can see it's got a lot of stuff going on inside of there, and a lot of you guys probably don't know anything about what this means, but I'm going to break down every section of this scope or this reticle and tell you exactly what it does mean and what we can do with it. So this is a little bit zoomed up. You can see it's got dots, it's got lines, it's got numbers and lines and stuff everywhere. I'm going to break it down. This is even closer up. And this tells you exactly what every single measurement is on here. Cluttered, right?
Yeah.
All right, so this picture didn't turn out very good, blown up like this, but you can kind of make up what these lines are right here. It's what we're going to go over first. So from this stadia line right here over to this first big line, that's 1 mil. And the next one you have 2 mils. So each one of these lines in between here is 0.2 mils. So you got 0.2, 0.4, 0.6, 0.8, and 1 mil. And it's the exact same thing going up and down right here. You got 0.2, 0.4, 6, 8, and 1 mil. So that's what the measurements on there are. And right here, I'm going to break this down later and what we do with it. But we've got from here to here is 1 mil. And from here to here is 1.2. And we got 1.5, 0.6, 0.7, 0.8, 0.9, and 2 mils. I know you're probably wondering why it's even like that. Like I said, I'm going to go over that in more depth later so you can understand. But it's one of my favorite features of the scope, actually, besides the wind dots. But this has been a huge help for the scout sniper community and shooters that do unknown distance shooting. The next thing are these lines that were on top. I'm going to have another chart later, but what these lines are up here are, they're really quick distance reference charts. So I'll try to bring it up. So if you put a target from this line to here at 12 inches, so you know the average person from shoulder to the top of the head right here is about 12 inches. So that's why we use the 12-inch drill, because we, shoot people or measure people, whatever. But from here to here is about 12 inches on the average person. So we use this 12-inch marker. So if you decide that you put someone's shoulders here and the top of their head here, you've got that 0.9. So right here, 338 meters away is about what they are. So for the dope for a 308 gun, these right here are your dopes. So you've got 1 mil, 2 mil, 3 mil, 4 mil, and 5 mil. So if you're being really quick about it, you see somebody walking away or standing there, you need a really quick reference. Put their shoulders here, their head here. Okay, you got 12 inches here, my dope, 1. It's really quick. And that's how you hold 1 mil over top of that person, or if you're shooting at their chest or whatever, you hold 1 mil above their chest and that bullet's gonna impact at that 1 mil mark. All right, does anybody not really understand? Yeah.
The shoulder at the line or the head is over the line?
So the shoulders will be here,
Oh, okay.
and the head will be here.
Oh, okay.
So just like this,
Mhm.
right here, shoulders, head.
Oh, okay.
So that's your 12-inch rapid range
I see.
mark. So like I said, for a 308 gun, you take these numbers and divide it by 2.
Okay.
So this is actually, these numbers are in the scope, just like you see it right here. So you're gonna take, say you line somebody up here with a 308 gun, you take 8 divided by 2, it's 4, so you hold 4 mils over them, and that's gonna be your distance. So let's just say, what I say, the 6, so 4 mils, yeah. So 12 inches, they're at 761 yards.
500.
4 mils is actually a little, it's not really enough, I don't think.
You went down.
Yeah, you
That was
508.
18 inches.
Oh, did I? Okay, yeah. I was gonna say, that's quite a difference there. But yeah, that makes sense. 500 yards, 4 mils. That's still a little off. I think with my 308 gun, it's like 3 mils. But this is just rapid engagement.
Okay.
This isn't exact. So you're gonna hit them somewhere. It might be a little low, but you're gonna hit them, right? This is nothing to be, if you're taking a headshot, do not use this chart right here. Yeah, so those measurements, divide those by 2, that's for a 308 gun. If you have anything that's faster shooting, like 6.5 Creedmoor, 300 Win Mag, anything like that, you're gonna take this, divide it by 2, minus 1, except for this one. You're gonna take this and divide it by 2, and that's it. It's gonna be 1. The next one, you're gonna take this, divide it by 2, that's 2 minus 1 is 1. Next one is gonna be 3, 4, 1, 1, 2, 3, 4. That's for like really fast shooting guns, like the 300 Win Mag that we actually got for these Night Force scopes. But it's a lot of the stuff I'm going into is like really fast. It takes like forever to actually know how to use this stuff and go over. If you guys want to be here for 3 days, I can. But
Well, you can't.
what?
You can't.
But I can't. Yeah. Okay. So yeah, that's one of the features that we have here. That's a pretty big one compared to the old scope. Another one that I really like are these wind dots. So let me see if, do I have another one here? I'll go over here. So these wind dots are a pretty big advancement for us also. It's a really quick reference, just like that 12-inch drill, on where to hold if you're holding for wind. So I know for a 308 gun that each one of these is 4 miles per hour. So if I'm holding at 4 mils, like I am on that quick engagement drill, if I'm holding at 4 mils, which would be right here, and I need to account for an 8-mile-an-hour wind, I'm gonna hold right here, 8 miles an hour. So that's exactly where I'm gonna hold to hit that target. So instead of looking at my dope chart and saying, all right, I need to dial 4 mils, I got an 8-mile-an-hour wind, what's my hold for that? Whatever, 1 mil, 2 mil, you know, and dialing all that, you can hold everything. You can hold wind, you can hold dope, everything is right there. So you can hit multiple targets out on a range really quick with just holding. I think when I went to my last course, I don't think I dialed one thing. I held everything with these wind dots. And a big thing, if you miss, so say you're holding right here and you miss right there, then all you have to do on the next shot is hold with that one, just like it says here. So if you're looking at your scope, you shoot, and you have that scope in the exact same position, the target is, you know, there where you're held, it impacts there to the right of the target, then you just got to hold right where that impact was. Anybody confused? I'm sure somebody is. Yeah.
That makes sense.
Wouldn't you go further left if you missed to the right?
Yeah.
Yeah, so
pushing
he's moving the target.
You're pushing this over here,
reticle's
so
gonna go left, the
1,
target's
2,
gonna go
3. So now you're holding all the way over here to get farther. So you're pushing that reticle farther this way.
Oh, I see. I was kind of wrong. I was kind of.
Yeah. So
I got you. We're good.
I'll draw it out for. I know somebody out there is confused.
While you're drawing it out, when you're looking through the scope, how clear are these dots and like these ticks?
It's actually really clear.
Oh,
Yeah, you would think that it's so cluttered that
Yeah.
everything just mushes together, but it's not. It looks just like this, actually, when you're
looks
looking
better
through
than
it.
that. These are like $2,500
Uh, Yeah, I mean this is a pretty blurry picture, but it looks fine.
It's like 17.
Find it for sale.
I was like, well,
It's not.
I'm like,
You
you
can
guys kind of make a
scale
hold,
it.
I look at the wrong dot or something.
Well, I mean, that's all, every single, what's it called? Everything's numbered on there, right? So you know where you're holding.
Yeah, it looks exactly like that. It's got the numbers and everything on there, so everything's pretty quick. So if you've got this target right here, and let's say, I'm gonna try to draw this out. This is your main line, and you've got 1 mil here, and then 2 here, and you've got 3, and then 4 here, and you've got your wind dots, 1, 2, 3, 4, just like that, because the 4th one is bigger, you can see, and that's so that you can quickly, rapidly guess, or say like, all right, the one beside that's 3, and that's where I need to hold is the 3rd one. So if I'm shooting at this target, and let's say I'm holding this 2nd one here, and I'm trying to hit over here somewhere, and it hits here, then all you're doing is pushing this reticle that way, because you know you're gonna hit farther to the right. So you need to push this reticle farther to the left, so it's actually gonna line up 1, 2, 3 right there, once you push it farther.
I have a question.
Yeah.
I don't know if I'm getting ahead of myself or anything, but so this is like quick engagement stuff.
Yeah,
So like in the movies where they got like the guy with the spotter, and he's like saying all these numbers. Is that like with the mills? Is that what he's talking about?
yes.
Okay.
Yeah, most likely, I think I know what you're talking about, yeah.
Okay.
When he says hold like
Right.
5 over,
Yeah.
or whatever, yeah, that's what that is.
Okay. Cool.
Yeah, so these aren't, a lot of people will think that this is 200 yards, 300 yards, 400 yards. That's not what it is. These are measurements. So when you get your dope and you go to the range and you shoot a lot, you're gonna figure out what trajectory your bullet is. And at 500 yards, you need 3.1 mils to hit center mass, hit somebody like right in the medulla oblongata, you know. So you're gonna be holding 3.1 right here in between that 2 and that 0 line. With these scopes, you can hold like everything all the way out to 1,000 yards. And it's like exact. You don't have to dial anything. You can if you want, but I pretty much don't even dial with these anymore. I just hold everything.
Does the wind call matter more at your target or at you?
Both.
I'll answer that question with another question. If you shoot a bullet from the tip of your gun here, right, and the wind's blowing right here at the very start of your muzzle, is it gonna push that round farther here off, or is it gonna push it farther away from the target down here if the wind's blowing here?
I'd assume since it's moving faster out of the barrel. No?
As soon as that bullet exits right here and that wind's blowing at the barrel, it's already starting to drift. So if it starts drifting here, you're gonna end up, you know, like all the way over here. But if it starts to go straight and then it starts drifting down here, then it's only gonna end up here.
Alright. Is your bullet moving slower at the target?
It is, but
The earlier you change directions, the more offset it's gonna be.
yeah,
Like that.
I mean-
that momentum's gonna be applied earlier. But speeds of
rotation's not that
well,
big deal. but-
speed, like wind speeds can change across a large valley if you're shooting. Like it depends on the conditions of your environment.
Depends on how far you're shooting. How far are you shooting?
800 yards.
Okay, so you could have 3 different wind calls in between 800 yards. You could have a right to left wind right here, and then a left to right down here in a valley, and maybe you got some trees down here and you don't have any wind.
So do you even try to get a wind call for distances more than, like...
You always get a wind
No,
call.
I mean in the sense of, let's say the closest 500. Are you caring necessarily at what it is 300 yards or 300 meters in, or are you really caring like right where you are? Because there's no real way to tell 300 yards away.
So there is a little bit. The way you focus your reticle, like the way I would focus this reticle or a spotter scope, if you put it on the target and then back it off towards you a little bit, you can see what's in between you and that target. Or if you want to focus it closer to you, you can focus it like 100 meters in front of you and see how fast the wind is blowing in front of you. In the reticle, over time, you'll be able to tell how fast the wind is going by the mirage. And it's a skill that's acquired over a really long time, reading wind. You read the mirage, you read the grass, you read the trees, you got everything. You can feel it on your face. But over time, it just comes. It's like second nature to you. But to answer your question, I guess, the closer to the barrel it is where you want it the most. That and wherever your max board is. So if I've got a target right here and I'm shooting from here, that bullet is going to come up and then it's going to start to come down. So right here is your max board. That's where all that wind high up on the off the ground is going to hit that bullet the most. So between here and here is where you want to get your wind call.
Yeah.
You don't want to completely forget about this, because if you got a bunch of trees right here and you only got like a 4 mile an hour wind, then you down here you don't have any trees and you've got a 10-mile-an-hour wind, you want to account for that. But off the bat, I mean, once you start shooting from here and the wind starts blowing it, then it's already off track.
Got it.
So I think we pretty much covered everything. This right here is the exact same thing as right here. We've got the 0.1, 2, 3, 4, and 5 mils right there. And next I'm going to go over how we use that, why we use that, and why it's such a big feature, and I think one of the most important things for us. I'll come back to that. So, range estimation. So, for unknown distance shooting, for us, say we don't have a range card or a range finder or anything, just like that 12-inch drill, it kind of gives you a quick measurement of how far that distance is from a target. So, say I got a target right here, and I don't know how far away it is. I used this scope from here to figure out how far away that target is. So let's say I measure from here, the top of the target to the bottom of the target is 1.4 inches. 1.4 inches, or sorry, 1.4 mils. So 1.4 mils, so I take, I would start from up here, because from down here there's a big gap in between these. So I would start from here, go down 1.23, or sorry, 0.1, 0.23, 4 mils. So let's say that target fits exactly in between these lines right here. So I'm gonna take this formula right here. If I want to find it in yards, I can also find it in meters with this formula down here. But for yards, I can take the size of the target in inches, which would be usually 40 inches is what the average person is, from the top of the head to about the waist. So 40 inches times this number right here, and divide that number by the size of the target in the mils. So divided by 1.4 mils, and that's going to give me the range. So over here, prac app, if you guys want to get out your calculators, you can. But example, we have a 40-inch target, and you mill it out to 1.3 mils. So okay, let's say it's 1.3. The formula will tell you it's 781 meters away.
Not close.
Huh?
You saw 1280?
I was like 1,000?
No, so that formula will give you, if you do it for the meters one, the, what is it, 25.4? So if you do 25.4, it's going to give you 781 meters away. So for my gun, which would be, it's going to be closer to 800, it's going to be in between here. So 6.6 on your gun at 781 meters. So that's with a 1.3. If you dial your gun or hold at that level and you shoot and it's actually 1.4, then it's only 725 meters. You're probably going to hit over it because you dialed too high, right? So one of the biggest things, when we used to have this scope right here with this reticle with the dots, what do you guys not see in between here? Point 1, 2, 3, 4, 5, right? So it's pretty much, you were just swagging it before. Yeah, you could find out 0.5, or sorry, 1 mil, and from here to the top of this dot is 0.4. The width of this dot is 0.2, and you can go from the center of that dot is 0.5 and then down here is 0.6. So you had pretty much every single number to work with except for 0.3 and 0.7 before. But now with this new reticle, you can do everything down exactly to 1.3, 1.7, 0.3, 0.7, all that. So that for us was huge because if it was, like I said, a 3 or a 7, or sometimes even in that dot, you got 0.2 mils that you can mess around with in that dot and not know exactly what you're aiming at or setting your alignment up with in that reticle. So a lot of people were missing high, low because the range S was off, you know? So that's why I like this feature so much. You can also do width of a target with these, but I like doing height because with width, if you have a person standing like this, they're exactly, 20 inches wide. But if they're bladed like this, they're not 20 inches wide anymore. It's like 18 or 16, something like that. So a bladed target isn't, you're always going to be 40 inches from here to here, but like this is all different all the way around. You know what I'm saying?
Right.
So that plus the wind dots has been a huge game changer for us.
So when you have that big math equation, are you sitting there with your calculator, or are you just doing it in your
No,
head
you
because
have
you're
a
a
calculator.
wizard? Okay.
I'm not that smart.
I was like, what? He's a wizard and I even know.
No, you have a calculator.
Do you guys usually measure out in yards or meters? I feel like it
Depends
makes
on
more
where
sense
you're.
in meters.
That's a good
In
question.
sniper school, you do both.
Yeah.
Like 1 week they might be like, all right, this week we're gonna do all yards, and the next week they might be like, hey, we're gonna do all meters. For stalking, like you guys know what stalking is. If you watch the what is it, Surviving the Cut on YouTube, Scout Sniper Edition or whatever, and they're crawling through the grass in their ghillie suits, that's stalking. So when you're stalking, in order to take a shot, you have to be within 300 meters. You don't have a rangefinder or anything like that, or a sketch kit, and you have no freaking clue where you're at, so you have to do the range est before you take that shot and they come and find you or whatever.
Or get within
So-
100 meters.
Or get within 100 meters, a good freaking luck. So they let us do meters most of the time because you could be, it's a little bit farther away. It's like 315 yards or whatever. But every little bit you can get. I've been at 305 yards before and money. But yeah, it just depends what you're doing, really.
Yeah, that always looked pretty gangster when you watch him do it. And then, well, dude.
I like using yards because most of my range cards are in yards. This is a range card from my gun that I built, like I have at home. These are the yards. This is the dope. This is the exact wind chart and everything for my gun. What?
What? No, that's cool. I can't build one in California, but
Hey, you can. Shut up.
my Cali
The government just can't know about it.
Yeah.
You guys know people.
But yeah, that's what a typical range card for me looks like. Or I usually have one of those quarterback sleeves like we have for the combos and all that stuff.
Sweet.
I have one like that, and I'll have a range card like this, or I'll have a couple of them that I can write on and stuff. I can always change it if I need to.
That's pretty
With changing that, I mean, it, like you guys know, you hear rumors or about it on Bob Lee Swagger or whatever. Like, there's spin drift, there's temperature, humidity. Temperature is the biggest, one of the biggest thing that changes actual elevation and dope. Humidity, not so much, but temperature and barometric pressure, which is something you can find on a weather station. Those are the two biggest things that change the elevation. The hotter it is, the lower this number is going to be. The colder it is, the higher this number is going to be. So if it's really freaking cold outside, you got to aim a lot higher over the target to actually hit it. If it's really hot, you have to aim a little bit lower. So this is for, I think this is for 70 degrees. outside temperature. So if it was 100 degrees this number might be like 8.2 or something like that. If it's 20 degrees outside, this number might be like 9. It just depends. So that's one way to range S was with the reticle. Another one is a range card. This is the Mackey Hall Barracks in Hawaii. This is actually a drawing that somebody drew, and they thought that it was so good that they put it in the Scout Sniper textbook and for everybody to see. It is a really good drawing, though, right?
Yeah, it is. I thought you did it.
No, heck no. But yeah, this would be a really good range card. You can get ranges from here. If somebody was standing over here, you try to get as many ranges as you can, and you put them, like, see how these are numbered? You got 12, 4, 13, and down here you've got everything, what it is, and you usually have a range with it.
Target reference points.
Yeah. So that is actually a really big one when you're going through school, because over time they'll start cutting the amount of time you have to range S with your scope until you get down to like, hey, you have 5 minutes to use your range card and find out your distances to your targets. So every time you shoot at the range over like a month, you're shooting at rocks and dirt piles and whatever you can find out there and getting target reference points. This is another one. This is, it was funny, I pulled this picture up and I was like, I know exactly where it's at because I have a range card that looks exactly like it. It's from Mountain Sniper. It's up on Rocky Mountain. I think these things go all the way up to like 1,500 meters or something like that. Like right here was like 1,000 meters. This area was usually where they had the longest target.
Where's this at? Pendleton?
No, this is Rocky Mountain, Nevada.
Oh.
When you go to Mountain Sniper up in Bridgeport, you take a week or a week and a half or something. You drive out to Rocky Mountain and you're up on this really tall freaking mountain looking down at all this crap for a while. In the morning, you shoot up here all morning and you go down for lunchtime. You go down here to the range and you shoot pistol and carbine down there for a couple hours, and you come back up here and you shoot until dark, and you do that for like 8 or 9 days.
Yeah.
We had a couple of days where the wind was 80 miles an hour. Not kidding, 80 miles an hour. It was, you couldn't even walk outside without blowing over. Like, it was rough. We couldn't even shoot. Like, after 40 miles an hour, you're just guessing. You can't even shoot. So. That is the schoolhouse in Pendleton. And that concludes my class. Is there anything that you guys want me to go back over or that you're interested in? Yes.
I just had a question. I remember them mentioning something about like a cold barrel shot, like the first shot you shoot's cold.
Yeah.
And it can affect your shot. Like, how do you?
Cold
vent
bore,
that?
clean
Yeah.
bore, kind of the same thing. So that is something that over time also with data, you'll go out 1 week with a clean gun. You know, obviously you cleaned it before you went out there and it's cold. You'll go out and you'll write down exactly like on a piece of paper, like in a data book that you usually keep. You'll write down where your first shot was, and it's different for every single gun. So you got to figure out your gun. You got to keep the same gun and collect that data. Then the next week you go out, same thing, clean barrel, cold gun. You go out and shoot, and if it's consistent, then you got a pattern.
Okay.
If it's different, then obviously you need to try that for a couple more weeks or months, whatever it takes. But over time, you'll get a good reference point of where that first shot's at.
Okay.
But that goes into things like the powder that doesn't get blown off, that doesn't get fired through the gun, and copper. So every time you shoot, copper actually comes off of your bullet and it lines the barrel of the gun. If it has any rough spots, like any indents or anything like that, which every barrel does, no barrel's perfect. So over time, the more copper and more stuff that you fill those gaps with, the finer your gun's gonna shoot. You're gonna have a tighter group. Once you clean all that stuff out, then you gotta start all over, pretty much. I usually try not to do that very often, clean all the copper and everything out. I just clean the powder and all that stuff out. Just do like a quick sweep. Does that answer your question?
Yeah, it did.
Anything else?
That's a good question.
That was good.
That was a crack app. What about a
Crack
Crack
at
at me.
rifles.
Hey, Zach, put a can on your head, and I'm gonna try to shoot you out.
Got it.
what about the spin of the
All right,
earth?
that
You have to do
concludes
that.
my class.
That was good. That was cool.
That was
That was a lot. Like, holy shit.
Yeah, it's,
That was actually enjoyed that.
like I said, if I went into detail about every little part, like we'd be here forever.
It's just like the basics of ranging.
Yeah. The biggest thing I wanted to do that for was like Gunny said that she wanted it to be something about your MOS or something you wish you learned a long time ago. I know a lot of Marines like to shoot in their own time, like out of the Marine Corps, and they buy scopes and they have no freaking clue how to use them or anything like that. So I wish that I knew this stuff a long time ago when I first started shooting, so maybe this will give you guys a reference of how to go about buying a scope or what kind of features they do have. Even after I graduated Scout Sniper School, I was like, man, I'm like the subject matter expert, I'm a badass, I know everything about shooting. And I went home on leave like 2 weeks later, and I went to a gun store and I was just looking around as one guy started asking me questions. I was like, dude, I don't know anything that you're talking about. I'm an idiot. So then I really got into studying ballistics and stuff like that. I got a couple of Brian Litz's books, and Brian Litz is an actual rocket scientist. He used to work for NASA, and he had a hobby for long-range shooting, and he was on the American Olympic team for shooting long range. And now he doesn't work for NASA anymore. He just studies ballistics and writes all these books, and he goes around, does seminars, and he's always testing new bullets and new things, new guns. He's like really smart. Reading his books is mind blowing.
That's pretty cool. No, thank you.
Yeah.
Oh,
Hell yeah.
so like for a reference for this, like to use this with an optic, it only really applies to a first focal plane optic as well.
Yes, so there's first focal plane and second focal plane. So first focal plane is an optic like this, which would have a reticle, and it changes as you, it changes to the distance that you're shooting at. So first focal plane, no matter what you're zooming in and out of, the reticle stays the same at that target. So if you're at 3 power and you read 1.4 here, and then you zoom into 15 power, you're still at 1.4. With a second focal plane, it doesn't do that. You might be at 3 power, which is where you would range everything from, and it's 1.4, and then you zoom into 15 power, and it's gonna be like 0.2, because that reticle is gonna get really, really big when you zoom into it.
Oh.
So it's like as you, can you pull up the optic or the reticle?
So it's like a camera. Right?
Yeah. So you see how this is. If this were a second focal plane, right? It means that the reticle is closest to your eye. Speaking from like the objective lens to you, you have the first focal plane, which is going to be that objective lens, right? Then you'll have the lens that magnifies, right? And then you'll have the reticle behind that. So then the target will get bigger, and this stays the same. So then these angles are going to be like, hey, your target's there, right? That's this angle at this is going to be a lot smaller than, or a lot bigger than this angle right here, right? So your holds are going to be different. But then if you place it right closer, And so this would be,
Yeah,
that would mimic like
It'd be
a,
just like this. If your
Yeah.
target right here, you measure it, it's at 6.2 mils right there.
And then
Or
you
not
start.
6.2, sorry, it's like 1.2 mils. So I'm holding it, the bottom of it's on that 7 line, and the top of it is right above that 6. So it's about 1.2 mils.
and
And
you
I
start
bring it
zooming
in, see how it's getting smaller? Now it's only like 0.6 or 0.5 mils. So that's a second focal plane scope.
Oh.
With a first focal plane, it's gonna
Proportion.
stay this size all the way through. Obviously can't mimic it, but
That's pretty cool.
So when you're actually
Yeah.
looking through like a specific reticle like this, it's going to be, all of these are going to be pretty small when you're completely zoomed out. But then when you go the higher powers, then you get that finer detail.
So get that optic. Got it.
first focal plane, I don't know why second is even a thing.
Yeah.
That's
That
lame.
was like the traditional, is like first focal plane,
Digital
and that's
zoom.
where you get the regular crosshairs.
Yeah.
Like digital zoom versus optical zoom.
Yeah.
Digital zoom. like
Anything
big zoom.
else? Any questions?
Good luck to whoever has to follow up this class.
What are your
Yeah.
what are
You do.
what are like
You're gonna tell us how to
the quick
purify
pointers
water.
that you would give
For what?
for like shooting like
So
if I want to
glacier
get like
water
a sniper
better than-
for not a sniper, but
Ozark?
for
Anything's better than Ozark.
You want to get a scope for a long gun?
versus
Depends on what you're gonna use it for.
Pretty cool. Actually.
like just like shooting, just like long distance shoot.
What's long
Just target
distance to you?
shooting?
I don't even know.
Well, that's the thing. It's long
That's
distance
it.
for some
There's-
people's
there's-
500 meters.
There's a
but that's
scope
not-
out there for everything. If you want all around, you can use this scope for hunting, for people, for targets, whatever you
I'll say
want.
like at least like
Ex-girlfriend.
500 plus.
Yeah.
Just long distance.
And even 500 to 800 isn't really considered
Long
range,
distance.
so
Yeah.
that's still like
1,000.
TMR type.
You're not really long range until you hit the transonic, the subsonic mode.
What's that?
Where your bullet slows
So-
down out of supersonic, right?
I brought this in case somebody did ask that. So,
Oh, cool.
ballistics.
Nice.
Balls.
It's the next class.
Love balls.
So with ballistics and shooting long range, you've got supersonic speed, which is the bullet in feet per second, right? The bullet speed through the air. So you've got, where's my pen? All right, so see how when you shoot from here to the target down here, your arc is pretty straight all the way here, and then it starts to fall really fast down here. So let's say from right here to right here is your transonic speed. And then up here you've got super sonic speed. Over here you've got
I like this class a lot more.
over here you got subsonic speed. So supersonic is anywhere from as fast as your bullet's going to about Mach 1, which is the speed of sound. So Mach 1 is 1,119 feet per second, let's say. So supersonic is anything faster than that. So about Mach 1 and faster. Then you've got transonic, which is that 1.2 to 0.8. So it's right in between subsonic and supersonic. Subsonic and supersonic actually kind of overlap. This one might actually go to like here, and this one to here. They kind of overlap, but transonic is that transition in between those two.
Okay.
So subsonic is below the speed of sound, basically.
Okay.
So when you're, have you guys ever seen the ballistic instruments that people use, or computers? Like you can just pull it up and tell what your dope is for your rifle.
Talk about like kestrels and
Yeah, like a Kestrel. There's a bunch of them, but I got one on my phone.
Oh like the applied ballistics.
I got
or-
applied ballistics.
That's what my brother sent me. Yeah.
Yeah, I love it. It's like $30 and you have it forever, as opposed to a Kestrel. It's like $700. The only advantage with the Kestrel has, you have in real time weather data. I use my applied ballistics app and it gets weather from the weather station. And it's pretty okay. But when you're actually plugging information into your Kestrel or your ballistic computer, you can shoot your gun at this range, and this range, and it will come up with all of the data that you need. So where's my phone at? Oh, my phone's gone. So if I have a 175 grain Sierra Match King bullet, hollow point boat tail, let's say that what?
So that sounds expensive.
Sounds like you get into Catalina wine mix.
Yeah.
So let's say that I want to find out the ballistics for that, and find out what all the ballistics are that I need for my dope, my wind, everything. So it's going to give me 3 ranges that I need to shoot at. The first one is going to be about, for a 308, I think it's like 800 meters right here, and that's going to be the supersonic speed. At the very end of that supersonic speed is where you're going to get the best range for that first piece of data. And the second piece is going to be at the end of that transonic speed. So beginning of subsonic and end of transonic. So let's say that's at 1,100 yards. So I need to take a couple of shots and get data for where I'm hitting exactly at 1,100 yards. So I find out that at 800 yards, I have to dial 7.3. At 1,100 yards, I have to dial 11.1. So down here is your third piece of data, and it's about 300 yards past the second piece of data. So right here is where your bullet is going to start to get unstable, and it's actually going to start to tumble in the air at some points. If you have an unstable bullet, because it's making such a quick transition down, it will start to tumble and pitch and yaw is what they call it, and do all kinds of weird stuff at this speed. So when you get ballistics and calibrations for this speed, it pretty much adds up everything that you need in between, so that you can just, I have a target at 1,000 yards and I need quick data. I just pull that calculator up and it's right there. But these 3 measurements, plug it into the Kestrel or a ballistic computer, and it'll figure everything out for you. As opposed to what we used to do is go to the range every day and shoot and collect data, write it down on a piece of paper, and then have to memorize it.
That's pretty cool. There's a lot of fucking math, I'm not gonna lie.
There's a lot of stuff that goes into this.
You're fucking brilliant, dude. Seriously.
Yeah, he's not actually good at shooting. All he does is math and take pictures.
No, that's awesome.
Yeah, we don't even shoot anymore.
That's also
We're
a
just
sniper.
surveillance and recon.
This is actually not the sniper scope. It's actually his camera scope.